Welcome to Latchem class. Today we'll be talking about chemical equilibrium constants. Imagine two football teams pulling a rope with equal strength. The rope is not moving, yet both teams are pulling hard. That is exactly what happens in chemical equilibrium. Reaction continues, but everything appears balanced. Scientists then ask an important question. Can we measure this balance? Yes. The measurement is called equilibrium constant, represented by Kc. This shows the relationship between the product and the reactant concentration when reaction reaches equilibrium. Rules for writing chemical equilibrium constant. When writing equilibrium constant Kc for a chemical equation, 4 things need to be considered. Rule number 1, only gaseous concentration is shown. Rule number 2, we do not write solid concentration or liquid because they are taken as a unit. 1. 3. Product is written up while reactant is written below. 4. Coefficient of a balanced equation is written as a power. You can see the reaction above. We have small letter A representing the coefficient. The same thing with B, C, and D. Now, these coefficients are the one written as a power of the concentration of each of the species. For the Kc, concentration of product is written on top with their powers. That's the coefficient in a balanced equation. And below we have those of the reactants. After substituting the concentration of the product with those of the reactants as shown above, then when Kc is greater than 1, it means the product is favored. When it is less than 1, it means reactant is favored. And when it is equals to 1, that means in the system we have equal amount of reactant and product. This is an example of a balanced chemical equilibrium. The equilibrium constant Kc for the above reaction, we can see that the concentration of the product is written up, while those of the reactant is below. And again, the balance coefficient, those numbers in front of the SO2 and SO3, is written as a power for the Kc. Now, after substituting the concentration of this species, and we calculate that Kc is either less than 1 or greater than 1 or equal to 1. In this example, the concentration of the reactant and the product is provided. All you need to do is to substitute it in an expression of the Kc and see whether the Kc is less than 1 or greater than 1 before we can conclude. After substitution, we discover that our Kc is 16, which is greater than 1. It shows that the forward reaction is favored. That is the product. Now, these are the interpretation. If Kc is greater than 1, product is favored. If Kc is less than 1, the reactant is favored. And when Kc is equals to 1, both reactant and product are of the same. We discovered that the equilibrium constant Kc helps us to know which side of a reversible reaction is favored at equilibrium. A large Kc means products are formed, while a small Kc means reactant dominates. Remember, equilibrium is not stopping. It is a perfect balance of continuous reaction happening at equal rates. Keep thinking like a scientist, and chemistry will always make sense. Don't forget to like, share, and comment. Bye!
Every day is a new chance to learn and grow with friends by our side. There's so much to know, from the ABCs to the stars up high. We're learning together, you and I.